e power x is equal to e power x, this implies that integration of e power x dx is equal to e power x plus c. So e power x is a unique function where the integration is the same function. Great, no? That means, what does it mean? E power x, when you're integrating, you get the same thing. What does it mean? Or e power x, when you're differentiating, you're getting the same thing. What is the importance of e there? The slope of e power x is equal to the value of e power x. Such a beautiful thing, you see that? Okay, so if I have e power x, okay, e power x function which is over here, the slope here is actually the value. That means when it starts at 0, it has a 0 slope. Observe, it has a 0 slope. As it goes at x is equal to 1, what is the slope of e power x function? It is e power 1. What is the slope of e power x at x is equal to 2? E power 2. That is the important. See, when we by heart the equation, we by heart just like that. But we have to understand differentiation means slope. That means slope of e power x at a point is equal to the value of e power x at that point. And whatever derivative, the beauty of this is, it is not the first derivative. It is slope of the slope also. If I draw a slope curve, see, for example, if you have a sine curve, when you integrate, what do you get? Cos curve. How do you get the cos curve? Is it plus cos curve or minus cos curve? Minus cos, is it? Plus cos, is it? How do you get minus cos or plus cos? Because you have to see the slope over here. What is the slope? Positive slope. Oh, sorry. Yeah, sorry. In differentiation, when you do differentiation, you get plus, is it not? So when you get plus, you get go over here. Now again you differentiate that, you get the sine again. So cos you differentiate, sine you differentiate, you get cos. Cos you differentiate. That means double integration of sine is sine itself. Minus sine, yes. Double integration of sine is minus sine. That is slope of slope. Slope of the slope curve. This is slope of the sine curve. Slope of the sine curve is minus of sine curve. That's why in simple harmonic motion, what happens is 180-degree shift. You understand? So 3 times differentiation will give you 180-degree shift in the sinusoidal curve. Phase shift. Yes. So first this one, you have 90-degree phase shift. Observe here. First differentiation, you get 90-degree phase shift. Second differentiation, you get 180-degree phase shift. You understand? This is how simple harmonic equation also works. So you see, first differentiation is what? Velocity. Second differentiation is what? Acceleration. So acceleration is always at 180-degree phase shift to the displacement. Huh? Velocity is 90-degree phase shift. 180. You understand? This is very important vibration. That means if the displacement is there, if it is at 0 displacement, acceleration is on the other side, 180-degree. You have to understand simple harmonic motion, a pendulum going here and there. See, when the displacement is maximum in one direction, where is the acceleration? What's the acceleration there? It goes to 0. Sorry. When the yeah. So what happens? You have the, say this is the displacement curve. Okay. If this is displacement curve, the when the displacement at the down is 0, okay, the acceleration is also 0, but it goes in the other direction. It is negative direction. Displacement is in this direction, the acceleration is in the other direction. You understand? When the displacement is 0, when the displacement is 0, the velocity is maximum. When the displacement is 0, the velocity is maximum. The acceleration curve is like this. As displacement increases, acceleration also increases, but in the negative direction. When the displacement increases, acceleration also increases, but opposite to the displacement. Because when it is at highest, see, a pendulum is there, okay? When a pendulum is there, I don't know how to get, while a pendulum is here, so what is happening? At the mean position, later on, this is maximum. In the mean position, displacement is 0. As it goes over here, where is the axis? It's trying to decelerate. Maximum velocity is here. As it goes away from that position, the deceleration is happening. Velocity is decreasing. Where is the acceleration direction? Other direction. Where is the velocity? Same direction as the displacement, but velocity is reducing. How do you state the velocity is reducing? See, the velocity is reducing. Simple harmonic motion. It's very simple. Huh? Exactly. Velocity is mean maximum at the mean position. When the displacement is 0, velocity is maximum. It's 0. Acceleration is the maximum there. Such a beautiful, simple harmonic motion it is. Correct? Uh, So these are all extra thing, whichever I got to think I'm putting it. So let us complete this things. Okay. So third one is d by dx e power x is equal. So you understood what is the importance of e power x. Each and every point I will tell you here like this. Because just by hearting the formula is not enough. You have to think about these things, is it not? You have to think about the beauty of these functions. Correct? So let us do one by one. Okay. Next. Yes, please. If you don't remember this, it will become difficult for you. All these things has to be remembered. There's no other way other than by hearting. You have to by heart. Yeah, you have to understand. That's right. Okay. One thing you have to understand is the differentiation is the slope, integration is anti-slope. Okay, that is how you have to understand. Okay. Integration is area. Keep in mind. Now here one of the main thing we have to understand that area under a curve gives the integration. So if you have, so see, very very important. Okay. So if you have a sine curve, what is integration of sine? Integration of sine is minus cos. Integration of cos, integration of cos is sine. Okay, let us have integration of cos. Integration of cos is sine. What does that mean? What is the area here? Okay, so if you understand integration of sin x, okay, so here starting very small area is 0 and it grows. This is the value of the area of this much. This area is this value, and then it goes here. This area, you see, this area, so this whole area from here to here is equal to the value here, and here there's negative area, so it negates, so this reduces, and then when it comes here there is one negative area, positive area, which is equivalent, so it comes down here. That part is equal to inside part. See, I'll repeat again. See, observe. Okay. If I consider what is the area here, this area A, this is equal to, when you push it here, this value, not the area, value. No, it's not. No, it's not. It is the value. So when it is over here, it's almost 0. See, let us understand. Integration of value. See, for example, 0 to pi by 4 0 to pi by 4 sin x is what? 0 to pi by 4 sin x is, sorry, pi by 4 cos x is equal to sin x, not minus sin x, sin x, right? Sin x plus sin x from where? 0 to pi by 4. What is that? Sine of pi by 4, 1 by root 2. Now what is cos of pi by 4? So integration of cos x, sorry, sine of pi by 4. Here only you proved, right? There only it's proved. So the value of sin x gives the value of the area under the curve till that point. In under the cos curve. Getting that point? So till any point you take from 0 to that point. So if you come till this point, for example, what is the area? 0, because there's a positive area, there's a negative area. Yes. Then again, negative area grows and it goes to maximum when it is over here. Is it not? And then again it becomes 0 at when it comes over here. Understand in this fashion. Exactly. Exactly. That's what sine and cos. Exactly. You did not know this? Knew this. Okay. I just wanted to check it. That's it. Okay. Because I wanted to know whether students remember this or not. Okay. Yeah, okay. And also the slope of this curve is equal to the value of this. What is the slope of this 45 degree? Tan 45 degree is 1. So what is the value here? 1. Throughout the all thing, you take here. What is the slope here? 0. What is the value here? 0. Exactly. Such beauty is the sine and cos. Yeah, reciprocal equity. But is it not beautiful? Exactly. So if you want Desmos, no, right? Okay. So you try it out. When you try it out, this can be a what do you say, for a 10th standard kid, this can be a very good exercise, assignment where he learns. Trigonometry is there in 10th standard, is it not? In 10th standard, this becomes a very important. This is what is the point of IIT coaching. These kind of things should be very clear. When concepts are clear, how can they not score well in JEE? Or how can they not score well in GATE now? Is it not? The concept has to be clear. Is it? Fine. Next. See, area till here. This area over here. No, this total, this much area is equal to this value. Let us do later on. We will do the area and all those things, and then we will see. Okay. So let us do an assignment like that later on.